Here with problem one, the Welbilt company produces two types of wood chippers, economy and deluxe. The deluxe model requires 3 hours to assemble and 1/2 hour to paint. The economy model requires 2 hours to assemble and 1 hour to paint. The maximum number of assembly hours, so we need to be less than that, is 24 hours per day, and the maximum number of painting hours is 8 hours per day. And so, as we've mentioned, what we need to do to begin these is look for a total in the problem. And so it looks to me like our totals are 24 hours per day available for assembly and 8 hours a day available for painting. So I'm going to go ahead and record those to my right. 24 assembly and 8 paint. It's helpful for me to put this line just so that I keep those two things separate. So our maximum number of hours available is 24 for assembly and 8 for paint. So whatever we have here needs to be less than those amounts. And now we have got that first piece. And so, as I've mentioned before, that is what I like to do first: identify my totals and label them. Now we need to fill in the information in the columns. And so, similarly to what we've done in the examples, we'll have a title. And then we'll have a couple values that go along with that title. And we will have a second title with a couple values that go along with that title as well. So let's see what we can find. It looks like we've got a deluxe chipper that requires 3 hours to assemble and 1/2 hour to paint. So we'll start with deluxe. Requires 3 hours to assemble. We'll give deluxe the X value and 1/2 hour to paint. So I will put 0.5 X again. We're using X again because we are assigning the X value to the deluxe model. Economy model is next. And the economy model requires 2 hours to assemble and 1 hour to paint. So we will assign the economy model the Y value. And then we need to remember that this is just like sum of the money plus sum of the money equals all the money. We are going to be adding on these all the time. So I do have my two inequalities for this problem, and I'm going to now be able to go over to GeoGebra and put this in. If you do need to write these down, do it now because I'm going to move these off screen. You can take a moment to pause the video to do that. And just as a quick reminder, the way GeoGebra works, to get a new sheet here, I do need to click New. And if I say don't save, it's just going to throw this one away and give me a new blank sheet, which is what I want in my case. And to move my grid around, I do need to get the white arrow over here so that I can do that. My inputs, everyone, I'm going to put in exactly what my inequalities are: 3x plus 2y. And we have to be less than or equal to 24 on this one. And then for the second one, 0.5x plus 1y, again, less than or equal to, and 8. Oops. So we do have our two inequalities. This is the region we're going to be looking at here. Again, this region, we're looking at the darkest region that is bound by the y-axis and the x-axis because we need to stay on quadrant 1 because that's where real things exist. And so we do need to create a line that goes on top of this, a line that goes on top of this, a line that goes on top of the y-axis, and a line that goes on top of the x-axis. Again, I could retype both of these and put an equal sign there, but to me it's easier just to say duplicate the input and then go back and just put the equal sign in. And as I mentioned previously, your GeoGebra will change these a little bit to simplify them for itself. Pay no attention to that. Just make sure that you typed it in correctly. And so to cover the x-axis and the y-axis, we do put in x equals 0, y equals 0. And again, we are bound by the y-axis, the x-axis, and we're looking for corners that touch or abut the dark shaded region. So if I click here and get to my intersect tool, I can see that there's a corner right there, a corner right there, and a corner right there. So in terms of part A for our problem over here, we have assigned the X value to deluxe. We have assigned the Y value to economy. And we have written our inequalities there on the iPad. So I'll bring this back up. I just assigned my variables. I had forgotten to do that initially. So X is deluxe, Y is economy. You can sort of see that implicitly here, that deluxe is with X and economy is with Y. And then graph the solution. We've got the graph. Again, there's no need to save this graph and turn it in. You can if you want to. I'm not going to stop you. But that is going to be what we needed for part B. So we do need to record those values though. So let's make sure that we get the values of point A, point B, and point C so that we can continue with the next step. So A is at 0.8. That would mean that we would be making 0 deluxe chippers and 8 economy chippers. B is at 4.6, meaning that we would make 4 deluxe chippers and 6 economy chippers. And then C is at 8.0, meaning that we would make 8 deluxe chippers and 0 economy chippers. Now again, this is the most perfect solutions to this problem. The problem being, we're looking to maximize profit in this one, it looks like. And so these 3 points will be the best opportunity we have to maximize profit, doing one of these 3 things. Yes, you could do something else, like produce 2 deluxe and some number of economy. But again, this is the best result. These are the 3 best results, and so these are the 3 results we want to test. So in terms of testing these for part C, everyone, part C, I'm not going to put part B on here because that's my graph that I've got on GeoGebra. The profit for the deluxe model is $15 per unit. So deluxe draws $15 per unit, so 15x. And the economy draws $12 per unit. How many of each unit will maximize the profit? And so we need to create a profit function, which is just however much we made from the deluxe and the economy combined. So the profit function will be 15x plus 12x. And we are going to test that for each set of points. So for A, we would have 15 times 0 plus 12 times 8. And again, I'm getting these values that I'm substituting in here from these points that we found when we graphed the system. Option B puts us at producing 4 deluxe models and 6 economy. And option C puts all of our marbles in the economy bucket. 12, oops, should be an 8 in there. So using Wolfram, everyone, we're going to go ahead and test these and see which one produces the best result for us. And so this is talking about profit. So again, we are trying to maximize the profit here. How many units of each model will maximize profit? That's a good thing for us to do. So we want to test these and see which one of these will make that happen. So we've got 15 times 0 plus 12 times 8 for the first one. That's going to put us at a profit of 96. Next, we have 4 of the deluxe and 6 of the economy. That's going to put us at 132, so a increase of nearly $40. And then lastly, we have all our eggs in the deluxe basket with no economy chippers being produced. That's going to put us at $120. So the best option for this company is to maximize profit at $132, produce 4 X's was the deluxe, and 6 economy. So as you can see from the example again, everyone, we have used GeoGebra and our graph and the corners to find the 3 spots right across here where the best options are. And it turns out that the best of those 3 options is to do this and produce 4 deluxe and 6 economy, getting our profit up to $132, beating both of these other 2 options.